So we have already completed the schematic. Now let's start with the footprint assignment. After the annotation of the component, the footprint assignment is done just by looking at the assign footprint. So you can just open this the window for assigning the footprints, and you can see automatically the footprints of the components will be listed here. Okay, so these are the components that we are using right now in our circuit. So how do you assign the footprint? So you just see the value C1 in CP is actually electrolytic capacitor. There are two electrolytic capacitors which I have named here. So CP is actually electrolytic. So what I will do is I'm going to assign the footprints. So it is an electrolytic capacitor. So what you need, and I'm going to search it in the through hole component now. So under through hole component, you need to search the footprint for this, and under radial. Okay, I will search it under radial. I think we will go with the radial footprints, where the diameter is 10 and pitch is 5 mm is more enough for this. Okay, so capacitor radial D 10 mm 5 mm. So I'll assign this footprint for this. Okay, say double click, it will be assigned. Now another is here. So what I will do is I simply copy over this and see the copy the footprints and paste it over here. This is another same category. And you have C2, C3, C4, they are all ceramic capacitors, and you can see that is disk type. So disk type is here. So what you do is you select it around here, disk. This is preferred for us, disk. Look at the footprint once. Yeah, this is more enough for us. So disk 3 mm and pitch width is 2.54 is enough for us. So or even this also, okay, doesn't matter. Okay, so I think we will go with the first one. You simply assign the footprint for that, double click each. Okay, then the barrel jack you need to assign. So barrel jack is that one we use for the DC power supply. So we have the barrel connector here. You can see here there is a barrel connector. So under connector you can find here barrel jack. Okay, under connector you have a barrel jack, and you see barrel jack horizontal. Just look at the footprint once, view footprints. So this is the footprints. Okay, simply assign that, double click and assign it. Okay, so just look at this, and one thing remember, pin number 1 is VCC. Okay, so in our circuit also we have assigned pin number 1 for that VCC. So this is now you see Q1 BC547 already assigned. Package is SOT, TO SOT package. You can check it here under package. Yeah, under the package of TO SOT through hole, you can find this actually already. TO SOT TO92. That's for the transistors. It is already assigned. Okay. Another is R1 resistor. So resistors you can assign. So you know where the footprint for the resistor. Choose under resistor. Under resistor through hole, you need to search. And the last case we actually choose the around, yes, that's over here. Yeah, you can choose any of these actually. I think I will choose something. Okay, so yeah, we will choose this. Okay, the R, I think here is the package. We will choose for this package. Okay, so 10 mm, give the footprint. So the pitch width is 10 mm, almost 1 centimeter is the footprint, the gap between that. So you can, what you can do is you can just simply press here uh, space, and you can see here it will go up to 10 mm, 10.16 mm. Fine, that is what the footprint. So we will use the same footprint. or even you can use 7.62, doesn't matter much. So we will use it 10.62, and I'm going to copy the same footprint for all the components. Paste the footprint, or let me select that and keep pressing this 10.16, this one. Okay, for all the R resistors you need to do the same thing. We are going to use the same footprint. Okay, all the R, same footprint will be assigned, only values are different, that's it. Okay, the another is SPST, so that is a switch. So what I suggest is you can go for some connector, simply a connector you can provide, connector of 2.54 mm. Okay, you can use this 1 cross 2 connector. Okay, here 2.54 mm 1 cross 2 connector. So under choose for this SPST, under SPST choose this connector pin header 2.54 mm 1 cross 2, because there are 2 pins. Okay, so use this and say okay, that's it. Oh sorry, control Z, control copy the footprint, and okay, so I think this is the one. So 1 cross 2, 2.54 horizontal or vertical, doesn't matter. So I think it is vertical, we'll go with the vertical. Okay, yeah, now there is one more component. I think I will delete this footprint. TSOP17XX is not there. Okay, we need to assign a footprint, and you see here TSOP footprint. So for that you need to open the data sheet first. So open the data sheet of this. So 55 timer data sheet you open and see what is the footprint for that. So device mechanical package, you can just go through this. Just look at this. The packaging details are here. Yeah, somewhere in the last page you'll get. Yeah, this is actually the surface mount. We are using the through hole package, so we should look into the through hole package here. Yeah, this is a PDIP package, plastic dual inline package, PDIP package it is. So you see here this gap is actually 6.6 mm and almost 6.6, and this is 2.54, means around 10 mm. Okay, 6 mm and 10 mm. The pitch width is actually 2.54 mm, that's given here. So let me use the same PD package. So LM55 I will use a PD package. So that is over here. You should search it in the package category P, package dip. Okay, search it in the package dip. So dual inline package dip, and how many dip is, this is 8 pin IC. So dip 8, width is how much? Width, this actually shows width. So width is 7.62, what is given here. I think ours is width will be increasing. So yeah, we will do one thing, PD 6. Okay, I think we'll go with this. 7.62 is given here. And here it is given as, see here, this is actually 7.62 is a total width here, 7.62. The IC is here 6.6, but the component with 7.62. And look at the width. This is around 10.16 or 9.02. Anyway, that doesn't matter for us, so we will use this package PDIP8 7.62. I think this is more enough for us. 7.62, at least we can match with one, so this package is more enough for us. Okay, PDIP8 7.62. This is the one that is supposed to use it for 555. Okay, then 74C926. Open the data sheet and look into that. 7.126, you need to open the data sheet of that. So go to the last sheet. I think it's given there in the first page only, it is given. 74, yeah, see, 18 lead plastic dual in package. Look at this. Here it is. 18 lead plastic dual in package. Dimension is given in inches, so we will just look at the specifications here. So it is PDIP 18. So we'll look into the last page to get the exact dimension. Yeah, that's here. Here is the dimension. Yeah, this is actually 16 lead. We are looking for 18 lead. Our 74 is 18 lead, so we need to look into 18 lead. Yeah, this is 16. Yeah, here is the 18 lead package. This is PDIP package. Look at this. It's again 7.62 is a outer dimension. This is actually almost fixed. 2.54 mm is the pitch width, you see, 2.54 mm. This is 2.54 mm pitch width, and other IC is 18, and this gap is actually important, which is actually given here 6.22, and the pin to pin vertical dimension, horizontal dimension is 7.62. So we will stick to that. Again, let's search PDIP 18 and 7.62. We'll go for this PDIP 18 7.62. That's it. I think 7 segment display, you see here already footprint is assigned. That's something very good. We have, oh, that's SMD actually. This is assigned for the SMD, but we are not looking for an SMD. We are looking for a through hole actually. So we need to change this as well. So what I suggest is, let me go through this particular thing. TSOP17XX. We need to see the footprint. We don't have a footprint for TSOP here. So for that, I need to open the data sheet first. So this is a pure engineering design, and mechanical also and electrical also supposed to look into all these aspects in the data sheet. It is not just choosing. See, this is a one. Okay, this is IC, the photo module, or this is a module that there. So this is a small module. You can get this. I mean, this is there in even every TV also. In TV remote control and TV remotes are working using the same IC. Okay, the same TSOP series. The number may be different. Now this IC will be in the receiving end. Okay, like in our circuit diagram, it is here. This is the one. Okay, U1 TSOP is the module that we are talking about. 3-pin IC, ground, VCC, and out. Okay, pin number 1 is ground. Correct. Pin number 1 is ground. Next is 2 is out. Then third pin is actually V out. Okay, same pin. Let's look at the dimension of the footprint, how to insert it onto a board. So if you want to insert it onto the board, just go to the last page where the CAD design details are given. So here is the design details. So there is only one package available, not much, and this is the design. So this is a front view, side view, and also you get a top view. Okay, so I think this detail is more enough for us. See here, we need to worry about this pin gap, how much it is. See, there are two pins are first ground, and pin number 1 and 2, they are 2.54 mm apart. 1 and 2 are 2.54 mm apart. Pin number 2 and 3, they are not given, but they given a dimension that pin number 1 to 3 gap is 3 into 2.54 mm. That means pin number 2 to 3, it is 2 times 2.54 mm. This is 2.54 mm. This is 2 into 2.54 mm. That means total gap is 3 into 2.54 mm. That makes sense. So it indicates that VS to VD, this pin to this pin, the gap is around, I think it is 5.08. If I am not wrong, 2.54 into 2 if we do. 4 plus 4, 8, 5 plus 5, 10, 0, 2 plus 2, 4 plus 1. So 5.08 mm. So 5.08 mm. That detail is more enough for us. We are not worried about the vertical placement of this, but if you are interested, you can just go through this. It is 12 mm roughly and 30 mm, 3 centimeter from the pin. Okay. So anyway, that doesn't matter much. But now what we need to do is we need to create the footprint for this. Okay, two components we need to create the footprint. So in the meantime, what I'm going to do is I'm going to delete the footprint for these items. Okay, this display, I'm going to delete the footprint because this is not the one where I'm looking for. Please delete this. This is not the one you're looking for. We need to delete this. Okay. So see, the dimension display that I supposed to use is given in the data sheet. Again, you get it in the Moodle. Please refer to the Moodle. The Moodle, I have given the footprint for all these components. So this is actually one I supposed to use. It's given. Okay, I'm giving this to you that this is the one you're supposed to use. So what is the pin dimension? Just refer to this physical package dimension. So there are pins in the bottom and there are pins in the top. Pin number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, like this. And the gap is 2.54 mm. And the other details of that packaging are mentioned over here. Yeah, other gap like what is the gap between the, I think more details you can get it in the, I think that's more enough, I guess, this detail. We can design actually. So 12.6 they are saying. One more dimension I need from vertical. Okay, this point to this point I need 1 second. Yeah, that's given over here. It's almost 15.24 mm. Okay, this is 15.24 mm is from this pin number 5 to pin number 6 or pin number this row to this row. Okay, top pin row to the bottom pin row, it is 15.24 mm, and pin to pin gap is given. I think if you get that, that's more enough. We can actually make a design based on this reference. Anyway, that details are more enough for us, so we will refer to that. Okay, so again we will design the footprint for this, and in the meantime I'm going to search if there is a footprint for the display. Okay, that's a better idea. Otherwise unnecessarily we need to do the footprint for the display. So just search in the display 7 segment. Just click on this display 7 segment and see if you find any 7 segment display of the dimension, if you can match to this, and which we need actually through hole. Okay, this is not the one. Definitely there will be a segment which is similar to one which we wanted to use. No, this is not the one. Okay, this is 4 and okay, let me check it with this. No, this is not the one. Then we can create one which we need. Okay, I think it's better we create it. That's not a problem for us. We can create a footprint. We'll create two footprints. One is for the TSOP, another is for the display. Okay. So this we assigned save and exit from this, and we are going to assign the footprint. Okay. So we need to design a footprint for two of the components. That's now our main job. So what we do here is we'll simply go to create a footprint. For that you need to click here footprint editor. Okay, just select here footprint editor. It will open a library for you what is available footprints, and now here you need to create a footprint. So now this is now 0.01 m, that's better. And what I'll do is I'm going to create a new footprint, and footprint name that I need to give is, I will give it as TSOP, and I will give it as dimension. See the dimension 3 pin, and the total width. So that I need to tell you what that is. It is 7.62. Okay, 7.62 mm. I think I'm just giving the width of the component. So width of the component is, TSOP is a 3 pin and its width is 7.62. That is a footprint. So I can easily search this component in the library. Okay, so I created a footprint for this. So this is the name. Now let me start giving the reference for this. So I will move this a bit down. So this also will move a bit down. So what I need is, I need to point the fab layer. Okay, just click on this fab layer here, the fab layer. I will take this 0 reference as a point. I'm going to make a rectangle first. I'm going to draw a rectangle. So take this add line and start from the 0. Just look at the now here what you need to see is, we need to see that dimensions. Okay, so what I am so keenly interested is this particular dimension. Okay, so we will do one thing, we will need to fix up this dimension one. So this is 7.62 is the pin, so we can say around 10 mm as our width here of the polygon, whatever the rectangle that we draw. And the component width, if you see, it's almost around 4 mm. Okay, and I think 5.8 mm. So 5.8 mm is and you see here the component upper width is 10 mm. Okay, the whole component width is 10 mm and thickness is around 5 mm. So I will draw 5.8 into 10. I will draw a rectangle of 5.8 into 10. So starting from here, I'll say this, I'll draw this line. You simply draw this line, and now edit it. Sorry, just select over this and press edit. Now here starting point of the x is 0, starting point of the y is 0, ending point of the x is 0, ending point of the y is, that is the width that I am talking about. The width of the component is, as I mentioned, look at this, width of the component is 5.8 mm. Okay, so minus 5.8 mm. Okay, so that is the width. So just zoom in. Okay, this is the width of the component. Now take one more line, and starting from this same point I will start and simply draw a line. Okay, just draw a line, escape, click, select over this, edit. A window will appear. Starting point of the x is 0. Starting point of the y also 0. Where is the ending point of the y? According to our, it is 10 mm. Okay. Ending point of the y is x is 10 mm, y is 0. This is actually the width. So one is height and width. Okay. So 10 mm. So here it is 10 mm. So what I'm going to do is I'm just going to copy this. Control C, Control V. Just paste it. Redo. So I'm going to select this, and you simply, and you can, what you can do is you can actually create an array here. I think array count, vertical count we can make it 1, and horizontal I think we will not do that. What we do, just simply say and duplicate. Okay, I'm going to place a component over this. Okay, just edit this and choose a position properly as 10 mm and y is 0. And again, okay, again I have ending point of the x, that is the starting point of the x. The ending point of the x is 10 mm and 5 point, as per the data sheet, 5.8 fab layer. Okay, that's it. There is a